Say you have disp method and it has to print, or I'll print disp itself, and this will print show, right? These two method in class A, both is having the for loop which is going to run 10 times. This is also going to run 10 times. And then in the main method you will also have a for loop. Assume main method is having for loop, and in this it is printing main I value, right? So this is a main method. Inside main method you have for loop, and in the main method I'll call show and disp, both I want to call. So here I'll call create an object a1 new a, and a1 dot show and a1 dot disp, these two methods, right? Now what is the execution flow for this program? Currently the execution flow is, when you will run this program, right? When you will run, then first when you will write in command prompt, if you write java and say test1, when you press enter, test1 class will be loaded. JVM will check main method is available or not. Main method is available. If it is available, JVM calls test1 dot main by giving command line argument, right? String type array. Then main method starts execution and control is first time here. So a for loop has to start. For loop is from 1 to 10 it has to run, right? From 1 to 10 it has to write, and every time it is printing main of I value has to be printed, right? So first time I value, when I value is 0, I value is 0, I less than 10, condition is true. So first time control is at this point, I value is 0, I memory is allocated, I is 0. Then from here control comes into the condition, I is less than 10, condition is true. If the condition is true, control comes into inside the loop, so it prints here main of I, and at that time I value should be 0, right? I value is 0. Then main body of the loop is execution is over. Then from the body control goes to increment, I will be increased, and the I value here is now 1. Then again from this control goes to the condition is again true, which is I less than 10, 1 less than 10, condition is true. Again control goes to this method here and it prints main of, this is 0, this is 1. Again body execution is over, control goes to this, and like this control runs 10 times. It prints main 2, and like this, this is main of 9 till 9, right? Till 9 it will print. Once this complete execution of the for loop is over, this complete execution for loop is over, control comes at this point and it creates an object a1 which is pointing to this object, and this object is pointing 1020, this is 1020, right? Then control comes into the next statement a1 dot show, a1 dot show, show method will be called. Then control is inside the show here. Now inside the show, again top to bottom approach, for loop, one loop will start, then another I local variable memory will be located somewhere, this is I, and I value is 0 first time. Control is here, right? Then control goes to the condition is also okay, control comes into the body executed, then control goes here, I will be incremented, then again control goes here, again control is inside the body, again here, like this it continues 10 times, and every time it will print show of 0, show of 1, and like this show of 9, like this it prints 10 times. Once complete execution of this for loop is over 10 times, control goes back from where it was called in this execution is over. Then control comes into the next statement a1 dot disp, then from here control comes to disp, right? Control comes to disp. Then in disp again top to bottom approach, it again for loop 1, I memory is allocated somewhere locally, somewhere I, and I value first time is 0. This is control is here. Then control comes to the condition is also true, control comes to the body is executed, go to updation, again here, again body, again updation, like this it continues 10 times, and every time it prints disp 0, disp 1 and like this tile till disp 9. Once this complete execution is over, then control is coming back to this here, and after that no other statement in this, so main method execution is over and this should be the output. So this is the execution is this flow, execution of this flow. Now what you are doing here is, first time this is the control here in the main method, and this control is running at this place 10 times. Here it is running 10 times. Once this is over, the same control comes to this part and again it comes to this. From here it goes to the show method and this runs 10 times. Once this is over, same control goes to disp, and from here again it comes into this part, and again this is also going to run 10 times, right? So same control here it is moving 10 times, here moving 10 times, here moving 10 times, right? Now at this point, when control is running at this point 10 times, what I want is, control is running at this point 10 times, then this execution is stopped, it is not executing at that time. Even this is also stopped, this is not executing. First it completes this execution 10 times, then control moves from here to this, then it moves here 10 times. When this part is executing 10 times, then this execution is done and this is stopped, this is not started even. Then at this point control moves 10 times, then once that is over, control goes back to this same place, then it goes into this place, then again it comes back into this, then here it runs 10 times, right? Then this is starting, at that time this is finished, this is also finished, and this is running 10 times. Same control is moving like this, right? So now what I want is, I want that when this is running 10 times, this is running 10 times, at that time it should not run only this part, this also should execute, this also should execute, even this also should execute at the same time. All three should execute at the same time. Maybe it is like this. So here one I in memory is allocated, first time it is 0, and here also another I is allocated, this is also local, this is also 0, here also another I is allocated, this is also 0. Then this has to run 10 times, this also should run 10 times, and this also should run 10 times. All three should run 10 times, 10 times, 10 times. But currently what it is happening, first it is finishing this part, then it is coming into this, then it is coming into this, right? Because it is one control running at a time. Now what I want, when this part is executing, at the same time this also should execute and this also should execute. All the three parts should execute at the same time. This is my requirement, this is what I want. And it can be in this way. Say here this is executing. Executing means I will be allocated, increased, right? So this is executed, one run is completed, I value is 1. Then it should execute this part also. Here also I value should be increased by 1. It should not continue the loop here. Here also should execute one run, means I value should be increased by 1. And then it should come at this place, here also I should increase by 1. Right? Like this I want. Then again maybe this is increasing, this is in second run, I is 2. Then this is maybe in third run. Then this should be in the second run, this should be in the second run. Again maybe this is also in third run, then maybe this is in third run, maybe this is in fourth run. Means parallelly all the three for loop should run parallelly at the same time. This is what I want now. It should not continue from one step to another step like this what we seen before, right? Currently it is the previous one. So in this now, if I run this program, it is one by one. It is not all together. All the for loop is not running together. It is one by one. Now if you just run this program and see the output once, see this. First in main method 10 runs completed. Then goes to show method 10 runs completed. Then goes to disp method 10 runs completed. I don't want like this. I want main method is running. At the same time show method also should execute for some time and disp method also should execute for some time, right? Means what do you want here is, you want when this block is executing, this also should execute, this also should execute. All three blocks should execute at the same time parallelly. Means you want multiple execution point at a time. it is not only one execution point. Currently how it is working, only one execution point, and that execution point is from the main. From the main this is executing. Once this complete is over, then control is coming into this, then this is executing, then again control is coming here, this is executing. One execution point, it is starting from this point and it is flowing. I don't want like this. I want this is executing, at the same time this also has to execute, at the same time this also has to execute, or maybe multiple other block also has to execute at the same time, right? Means you want multiple execution point at the same time. In multiple different places the program is executing individually. Okay, so this is called multi-threading. Multi-threading means multiple execution point of the same program which is executing independently at the same time, concurrently, at the same time, parallelly. All the parts are executing parallelly. This is called multi-threading. Or you can say multi-threading is like this. Assume you have written a program like this. This is some block of code. Here you have so many statements. So many statements you are writing like this, multiple, say maybe from 1 to 1000 lines of code you are writing in one program. Okay, one program. Then this part, this is one individual part. This is another part in the same program. Okay, you are grouping, you are dividing. This is another part and this is also another part. So in 1000 lines of statements, this is the groups you have divided like this, assume. And what you want is this part is executing. At the same time, this also has to execute. At the same time, this also has to execute. At the same time, this also execute. Means here is one execution point, here is one execution point, here is another execution point, here is another execution point. If it is like this, then each of this part is called as one thread. This is one thread, this is another thread, this is another thread, this is another thread. So in one program, multiple execution point which is executing at the same time parallelly is called as multi-threading, and each of this individual part is called as one thread. This is one thread, this is one thread, this is one thread, this is one thread. So same this one only, right? This is one only. This complete, assume this complete is one program inside test, including test A, main method, show method, disp method, like this, including like this. All these are individual. Complete, assume one program, and in that this is one part, this is one part, and this complete show I'll consider another part, this complete show is another part, and this complete disp is another part, and all these I want to execute individually at the same time. Then here I want a execution point, here is another execution point, here is another execution point, right? If it is like this, then this is called as multi-threaded environment. And each of this is one thread, this is one thread, and this is one thread. But currently it is not like this. Currently it is only one execution point which is main, and from main remaining two you are executing. Show and disp you are calling here, and it is executing, right? So like this I want all has to be executed individually at the same time. Then if you design it like this, then this is called as multi-threaded environment or multi-threading, right? So multi-threading definition you can say like this: one program is having multiple execution point which will execute parallelly at the same time, and that is called as multi-threading in one program, right? One program. Now this multi-threading you can do in different ways. Like, you know what is now you understood what is multi-threading. And before we have discussed one method, this is one method. This one method is one task or one operation. This is another task. This is another task. This is another task. Task is also I can say as command. This is one command. Show is one command. Disp is one command. Means these are the individual tasks which you want to perform on some object, right? This is one task I want to apply on an object. This is another task I want to apply on an object, right? So how will you call these show and disp? You have to call a1.show. Means what? A1 is a reference variable which is pointing to an object, and on this object you are applying show. This task, this action you are applying on this object. Same way a1.disp means disp action you are applying into this. So this is one task applied, this is one task applied, this is another task applied. right? So each individual part in multi-threading which is executing separately is called as one task. One task. Now if you want like this, then in JVM architecture you have seen control flow. You have seen like in control statement you have seen while loop, do while loop, for loop, all these things, or if else statement. What is the use of those if else statement or looping control statement is to control this flow, is to control the flow, right? First control is here, then control is here, then control is here, like this. I don't want the control flow like this. I want the control flow should be how I want. According to my requirement, I want to flow the control. Otherwise, it is top to bottom approach always, that you already know. So now, why it is executing this complete part once and then control is flowing at this point? Because it is only one control. This is only one control which is flowing to your entire application. Okay, it is only one control running. If you want multiple execution point, then what you have to do? For this part, assign one control. For this part, another control. For this part, another control. Like this. Different control you have to use to run different part of the program at the same time. Then how will you get this control here? Here one control automatically will come. That will be given by JVM. That is okay, fine. And the same control which is given by JVM is running at this point and running at this point also. But now what you want? Here one control is there, JVM is giving, it is fine. You want a separate control this first. For this part you want a separate control. Then how will you get the control? Very simple. You just declare this as a thread. This part you just declare as a thread. If you just declare this individual part as a thread, then these automatically becomes one thread. One thread. And each thread automatically gets a control. Each thread automatically gets a control and it executes individually. Right? So this is multi-threading environment. And you can assume if this is one thread, then this is one task. This is one task. Means one task or one action you should apply to a thread. One task or one action should be assigned to a thread, and the thread should assign a control for that particular part. Thread should assign for a control for that particular part, and it has to execute. Executing means what? The thread is executing means what? Thread is applying this action. This task means thread is performing that task. So what you have to do is, if you want a concurrent execution like this, then separate control is required. So for that control what you have to do is very simple. You this one you declare as a thread. This one you declare as a thread. This part, this complete show, this method, declare as a thread. Once you declare as a thread, it automatically gets one different control. This automatically gets a different control. Now what you have to do? You design a thread. Say this is th1. And what is the task of the th1? th1 task is show. Means th1 thread task is show task. Same way, you take another thread th2 and th2 task is disp. Disp is assigned to th2. th1 task is show, th2 task is disp. I'm considering, so this is considering as one thread. This part is one thread. This part is one thread. And each thread task is included. For first thread task is show. Second thread task is disp. Right? Means what you have to do? You have to create one thread. Okay, one thread. I'm creating one thread. This is one thread. And the task of that thread has to be assigned. The task is show. Create the second thread. Task of this thread has to be assigned. Create assigning disp. Very simple. Now you have to know how to create a thread and how to assign the task. If you just declare a thread and assign a task to that thread, then control and execution flow or concurrency, all these things comes automatically. You just declare this part as a thread, then concurrency will come automatically. Along with this it will execute. Along with this also it will execute. Now same way, for this you declare a thread, assign this task to that thread. That's it. Now when it will become a thread or this task will be assigned to a thread, a separate control will come automatically. And concurrency along with this or along with this also will come automatically. You don't need to do any other extra task for this. What is the task you have to do? Just create this as a thread and assign this task to the thread. Create another thread, assign this task to the thread. Right. So create a thread and assign a task to the thread. And each thread is performing individual execution. So it will work fine, no problem. Now multi-threading is, you can say multi-threading is to perform multiple tasks at a time. Multi-threading is to perform multiple tasks at a time individually. Okay, individually multiple task performing by multiple thread at a time is called as multi-threading. Or what you have to do, create a thread, assign a task, done. Create another thread, assign a task, done. So this is multi-threading, and each thread is performing individual task. So you can say multi-threading is multiple tasks actually executing individually. This is called multi-threading. But multiple tasks when executing at a time individually, you can say multiple task. This multiple task executing at a time you can achieve in two ways. One is, this is what we have discussed, you take multiple threads. Multitasking environment I want, multiple multitasking environment I want. Then what you have to do, you go to thread, take multiple threads, declare multiple threads, each task assigned to the thread. Then thread will be performing together automatically. You don't need to do anything else. Just to declare the thread and assign the task to the thread. That's it. And it will become multitasking. So multitasking you can achieve by using multi-threading, and each thread should have a separate task. Or multitasking you can achieve by using multiprocessing also. Multiprocessing. Take multiple process. Each process is performing individual task. Then that also you can achieve multitasking. So multitasking you can achieve in two ways. Either go with multi-threading and each thread has to perform one task, or go with multiprocessing and each process has to perform one individual task. Now what is the difference between multi-threading and multiprocessing? Now here you understood what is multi-threading. Multi-threading is one program, individual execution point, multiple individual execution point. This is multi-threading in the same program. So this is called multi-threading. Now what is multiprocessing? Multiprocessing is multiple process. What is a process? The process is when I am running this Eclipse IDE you are running, this is completely one process. Or if you run, say I am running a notepad, this is another process. This notepad is one process. Or at the same time you are running a BLC player, any other software you are running, MS Office or something. So that is called as one individual process. Now assume I am having one BLC player which is playing a song. At the same time I am having some browser and the browser is downloading a file. Then multiple process performing multiple tasks. Browser is a process. The task of the browser is download the file. VLC player is a process. The task of the VLC player is play a song. So different tasks you have assigned to different process, and different processes performing different tasks. That is multitasking. What is multithreading? Multithreading is in one process. This complete IDE is one process. And when you will run this main method, JVM is going to run the main method, right? So JVM is a process. Inside the JVM process, this complete program is running, and in that program these are small parts which is running again together. So this is called multi-threading, and when multiple process is performing multiple individual tasks, that is called as multi-processing. Multi-threading, multi-processing, both is used to achieve multitasking. So multitasking is multiple tasks executing at a time, performing at a time. That you can do by using in two ways. You go for multi-threading or you go for multiprocessing. Multi-threading means each individual thread has to have one individual task, and each thread has to perform those tasks at a time. Multiprocessing is task is assigned to multiple different process. The process is running at a time concurrently and performing different tasks, right? So this is multiprocessing and multi-threading. Now how will you write? How will you say that this is a particular thread? How will you tell that this should be a particular thread? This should be a particular thread. And how will you tell this should be a particular thread? You have to declare this part as a thread, and you have to say, okay, this is the task for this thread. Again, you have to declare a thread for this, and you have to say this is the part of this is the task of the thread. Like this, you have to say individually, right? So for that, what you have to do is very simple. What I'll do is, instead of writing in this way, instead of giving the task here like this, I'll take a class. A class I will not use. Here I will not use A at all. This is not A. And I'll take a class, A thread. And you have to extend thread class. You have to extend thread class. Very simple. And inside this, you run a run method. Override. This is run method is already there in thread class. Already there in thread class. And you just have to override. That's it. Run method, you have to override. Overriding. Same way, taking another class, B thread. Two different thread. Okay. A thread and B thread. And A thread task is this task. A thread task, just copy and put. This is the task of A thread. Same way, B thread task is this task. B thread task is this. Run this loop. Right. Okay. B thread task is this. A thread task and B thread task is assigned. So thread is ready. Task is assigned. Thread is ready. Task is assigned. This is normal class, right? Previously how we have created class by extending some other class. Same way, here also creating a class by extending thread class. Here also creating a class by extending thread class. When you extend a class, when you extend a thread class to other class, then whatever object you create for this class, or whatever object you create for this class, then that automatically becomes one thread. And if it is a thread, it has an individual execution. So if I say here ATH, A thread, ATH is equal to new A thread, and if I say B thread, BTH is equal to new B thread, right? Now this is becoming one thread and this is becoming another thread. Means you can say this is one thread and this is another thread. Task is assigned. Task is this and task is this, right? Now the thread has to execute. It is just an object creation. This is just an object creation. So to execute that, what you can say, ATH dot start, simple. BTH dot start, simple. Means start first task and start second task. Now what is first task? First task is show of I and second task is disp of I, right? Now this another task, right? For this we have not created any thread. This is still with the main. But for the second task and third task, we have created two thread. We have assigned the task and the thread is starting. Means the task is going to start. But for this, what will happen? For this, no thread. For this, no thread. Okay, fine. You run and check first how it is working now. Now you see the output. Output is main executed 10 times, disp executed 10 times, then show is executing 2 times. It should not be like this, right? Actually, it should not be like this. So for that, why it is showing like this is, inside the for, here I'll just write one thread dot slip. What it is doing, we'll see little later, okay? And this gives an exception, so I'll put that in try and catch. I'll surround that with try and catch. Thread dot slip. Okay, this is not a part of the task. I'm just writing it currently. Later we'll see why it is. Same way, here also I'll write the same thing in this, inside the task. And same way, here also I'll write in the same way. This. And now run and check. Oh, it is not done actually. It should be in the main, it should be out of the for. Not here. It is outside the for at this point. Remaining is okay. Run it. Oh, it's still not working, right? It should be Why not working then? Okay, it will work. You put this two statement before here only. Okay, before this. Now you check. Now it is fine. So main 0 first run, disp 0, show 0, like this. Now all the three is executing separate individually at a time, not one by one. Now you check main 0, main first run, disp first run, show first run, main second run, disp second run, show second run, main third run, disp third run, show third run. All the thread is working at a time. All the thread is performing its task at a time. But task we have assigned two, A thread and B thread. Two tasks we have assigned. What about this? It is not a task, right? It is not a task. Right, okay, we'll come back to this, how it is working. Now you understood very clearly, right, how to create a thread or how to design a task. You have to write a class, simple write a class, and by extending thread. And in thread you have already run method, you just override it, and inside that you define your task. What is the task you are doing? In the task, what we did here, we did in this A class we had show as a task and disp as a task. So these two tasks, now I have created one thread and task is assigned to this thread. Created another thread, task is assigned to that thread, right? Two thread, two task performing. What about the main? This main, this is not a task, right? It is a task, but how it is assigned? It is not like this. What happens is, now what we did, this is a thread, right? Assume ATH. This is ATH, reference variable pointing to an object. It is similar like a object how we are creating, same way. And in this, this is a thread, and same way BTH you have created, and this is B thread object, right? And in a thread we have given one task. What is the task? For loop. Sorry, not like that. Before this, I have a run method in this run. Inside the run method, what we did, the task is assigned inside the run method. And what is the task? For 0 to 9, print something. This is the task here is assigned. Same way, in B thread also you have a run. And inside the run, what is the task we have given? For 0 to 9, do some operation. Currently we have given just print something, PF, print something, right? Currently we have just given like this. So two thread we have created, two tasks we have assigned, that is working fine. What about this one? This we have not assigned as a task. What happens is, when you run this main method, when you execute any program, say I am writing like this, Java and test1, press enter, right? When you do like this, test1 and press enter, then this is to start the JVM. Java is start the JVM, and test1 is an input to the JVM. So this is JVM started. Inside the JVM, test1 is the input. So you have given, and JVM is started, now JVM is running. Then what JVM will do? Internally, JVM automatically creates a thread. Similar like how we are creating. Same way how we have created here. Same way JVM creates a thread first. When you write Java and test, this is to start the JVM, and test1 is an input to the JVM. The test1 is input. So this test1 came to the JVM. Here it is test1, right? Then what JVM will do? JVM creates a thread. How we have created here ATH. Same way JVM creates a thread, and how we have assigned the task in the run method. Same way in that run method, here also run method is there, and in that run method, what JVM does is JVM gives the task of the main method. Means inside the main method, JVM does like this, test1 dot main, by giving some argument, right? Means what? When you run any program, JVM automatically creates one thread, and in that thread run method, JVM automatically assigns the main method as a task. And main method is a static method. It is a static method. So JVM assigns test1 class name. What class name you are giving here? Test1. Same test1 dot main. Test1 dot main. So that is done by JVM. We no need to do anything for that. JVM automatically creates one thread. JVM takes the main method as a task, and that main method JVM assigns to that thread to execute. So we no need to do anything about that. But in our case, our task is different. These are our task, this and this. So for this, what we have to do? We have create an object. We have to create an object, and we have to assign the task to that particular thread. So that is what we are doing. Previously, what we did here, we have created one thread. We have created another thread, because that will not do JVM for us. That will we have to do explicitly. So we are creating thread A, we are creating thread B, and in A thread and B thread we have assigned the task, and it is executed. But for execution, you just create an object, will not execute. Just create an object, will not execute. What you have to do, after creating these threads objects, you have to say here start. Here also you have to say start. And what about this? When JVM will create, JVM assigns the task, automatically JVM calls starts. Then this is going to start. Start is a method, right? So same way, we are also creating and starting, right? Creating and starting. Now, each of these threads are having some name. Each of these threads are having some name. This is, we have created one thread. We have created another thread. JVM created a thread. The thread which JVM is creating, JVM gives a name for this. JVM gives the name as main. The thread which we are creating, we are not assigning any name currently. Name is not the reference variable, okay? Reference variable is different. Name is different. So for this we are not giving any name currently. So for this, name will be thread 0, thread hyphen 0. Automatically it takes if you are not assigning. For this also we have not assigned any name. So this name will be thread hyphen 1. Thread hyphen 1. Right. So when JVM is creating the thread, name automatically it is giving a main. We are creating thread, we are not giving name, by default it takes thread 0. Then next thread, thread 1, another thread, thread 2, another thread, thread 3. Like these thread names will be assigned automatically. Now I want to get the name. Okay, I want to get the name. To get the name, get name method is designed already in the thread class. Okay, in the thread class you have a method which is an instance method to get the name. You just say get name method on the thread object, and it gives the name. Okay, it gives the name, whatever name you are giving. So now inside the main task, suppose at this point, if I want to get the thread, and on that thread I want to say get name. So get name is the instance method, right? Instance method. If you want to say instance method get name, then first you have to get the thread object reference. For example, for this thread object I want to say get name. Then what you have to do? You have to get the reference. And reference is thread th. But who has created this thread? This thread was created by JVM. JVM is holding the reference. You don't have any reference for this. In the main method, nowhere is having this reference for this thread. No reference. So what you have to do? You have to get the reference for this thread. But what about your thread? Your thread is already having reference in this. This is a thread. This is thread. Current object, right? So in this, if I say plus, whatever is plus, this dot get name. This dot get name means current thread, current object. In this object means current object, and current object is the object which you are creating. Which object it is? ATH. When we will say ATH dot start, task is assigned. Where the task is assigned? Task is assigned inside the run. Means when you will say one thread dot start, it actually calls the run method, because the task is assigned inside the run method. Now if I say here this means what? Current object. And current object is what? ATH. And ATH is the thread object. Right? ATH is pointing to this. Means now here ATH. Inside this for loop, if I say here this means what? ATH only, current object. Or inside this here, if I say this means it is current object. So on this you can say just get name. Here also you can say just get name. It will give the thread name. Get name means thread name. So get name method you have to call on an object reference of the thread. So for your thread, you have the object reference, or you can use just this dot get name, or here also you can say just this dot get name. There is also fine. This dot, give one tab space plus this dot get name, right? This dot get name. You are getting the name. This means current object, and current object is a thread object, extending thread. So get name method, you can say here it is inherited also, okay? Get name method is inherited from the thread class as an instance in your A thread. So you are saying here this dot get name. This get name is inherited from thread class to your B thread, and you are saying here this dot get name. So it has to give what is the name? Thread 0 and thread 1. So current, now if I run this program, check the output, how it is giving. See this. Thread 0 and thread 1. You are getting the name of the thread, right? You are getting the name of the thread. So show method thread is 0. Disp method thread is 1. Show method thread name is 0. Disp method thread name is 1. Show method is 0. Means this thread name is thread 0 and this thread name is thread 1. Where it is? Thread 1. This name is thread 1, and it is giving here multiple times because you are running inside the loop, for loop. Inside the for loop you are giving, so it is giving thread 0 and thread 1. And you remember here we have used this means current object. Here it is this. One more important point you have to remember, when you create the thread you have to say start. Creating thread, start. When you will call start, what it will do? Start will internally call the run method because the task is inside the run. Here also when you will say start, it will call the run method. When JVM will say start, it calls the run method. Difference is in this JVM is assigning this task. Main task JVM is assigning. Here you are writing the task. Right. You are writing the task and executing. So now I want the main thread name. If you want to get the main thread reference you don't have. Other thread name reference you have, so you are just saying this dot get name. If you want to get the main thread name, then first you have to get the main thread reference here. To get the thread reference from any particular location, you have a static method in thread class. You can just say thread dot current thread. Current thread means which thread is executing this main, right? So this gives here the reference th is equal to. This gives the reference. Then the reference type should be of which type? It is giving the current thread type, right? So this type should be thread. Type is thread, right? Now on that you can say get name. Here it is one tab space plus th dot get name, right? So this is giving the main thread which is creating by JVM and the name of the main thread. This reference is actually for this main, means this one. This th is actually pointing to this, right? And on that you are saying get name. What is the name? Name is main, so it will give main. Now if I run this, it should give actually main. For this show main, it should give main, right? Now the output should be for this one main I, thread name is main, and for your task, what task you have assigned, for those it is here show I thread 0, disp I thread 1, right? Like this it has to print how many times? Here it is 10 times, here also 10 times, even in main also it is 10 times, right? So this should be the output. Now check once again the output, run it and check the output. Now this is main, second run, thread name is main. This is main because the method name is main. This is I value and the main thread name. Disp 2 thread 0, thread 1, disp 3 thread 1, show thread 0, main thread main, show thread 0, disp thread 1. Like this it is executing, and all the part executing at a time concurrently. Okay, at a time concurrently. Right. So this is the name of the thread. Now what you understood from here? When you just write a class, when you just write Java and test and press enter, test is an input to the JVM. Test is an input to the JVM. JVM creates one thread object. JVM creates one thread object. Inside the thread object, you have a run method which takes the task, and JVM